Lesinurad works by increasing excretion of uric acid. Naturally, it has its effects in the kidneys, specifically in the proximal convoluted tubule, PCT, of the nephron. A good understanding of glomerular filtration in the kidneys is necessary to understand the mechanism of lesinurad. Blood enters the kidneys through the afferent arterioles and secretes filtrate into the tubules. Then, in the PCT and the loop of Henle, water, ions, and essential compounds such as glucose are reabsorbed into the body. The remaining filtrate eventually exits through the collecting duct and makes its way to the bladder to be excreted. Overall, it is important to note that in the kidneys, substances, including urate, are initially secreted into filtrate, but gradually reabsorbed into the body through the tubules. Lesinurad works by specifically inhibiting urate reabsorption and ultimately increasing its excretion from the body. Here we see a close-up of the PCT section. Note the apical and basolateral membranes. Once administered, lesinurad binds to urate reabsorptive importers known as URAT1 or uric acid transporter 1 and OAT4 or organic anion transporter 4. These importers are located in the apical membrane of the PCT cells. They facilitate the reabsorption of urate from the tubule lumen into the peritubular capillary. This binding causes a conformational change in these membrane transport proteins, inhibiting urate's ability to transport from the renal tubules into circulation. It's important to note the advantage of lesinurad over other existing uricosuric drugs. OAT1 and OAT3 are additional urate transporters in the basolateral membrane of the PCT that potentially participate in urate secretion. However, many drugs such as tenofovir and emtricitabine, which are reverse transcriptase inhibitors, depend on OAT1 and OAT3 for clearance or excretion through kidneys. Existing urate-lowering drugs such as benzbromarone specifically inhibits URAT1 but not OAT4, thus having a lower efficacy than lesinurad. Probenecide, another pre-existing urate-lowering drug, non-specifically inhibits OAT1 and OAT3, as well as URAT1 and OAT4. This poses a significant problem of drug-drug interactions, as one drug prevents the excretion of other drugs. The ability of lesinurad to avoid interactions with OAT1 or OAT3 is a major breakthrough in solving this hurdle of clinically relevant drug-drug interactions.